Okay, so we have this interesting equation here, 4 raised by x plus x equals 1. But we are not going to be solving this graphically. But if you try the graphical approach, you will see that the answer is 0. So you are going to get x equals 0. Just take a look at the graph and see for yourself where the lines intersect. You are going to see that the value for x will be 0 graphically and otherwise. So we are not using the graphical method here. We are going to use a rigorous algebraic approach involving the Lambert W function. Yes, the Lambert W function. And what you need to know before using the Lambert W function is that if you can rearrange the equation, either the left-hand side and right-hand side, to be something like this, maybe a number multiplied by e raised to the power the other number. If you have it this way, you can now successfully apply the Lambert W function, which is this symbol here. Also, it also means the product log. If you apply the Lambert W function, in this case, you're going to get 2 as your answer. You're getting that same number, which is 2. It can also be in this form. Let's say you have 2x minus 4 times e raised to the power 2x minus 4 again. Notice they are the same, 2x minus 4 here and 2x minus 4 here. In this case, you can now apply the Lambert W function, and it will simplify to the same 2x minus 4 you started with, 2x minus 4. So in this video, we are going to try our best algebraically to rearrange the left-hand side or the right-hand side or both sides to be in this form, to be in any of these forms, so that we can successfully apply the Lambert W function. It's not going to be easy, but it is doable. So we are going to rearrange the left-hand side and the right-hand side or the right-hand side to be in this form. When it's in this form involving the e, you have the coefficient and the power being the same, you can now evaluate using the Lambert W function to get a single value, which is the value you started with involving the e, which is your 2. The same thing here. Here it is 2x minus 4 we have here, and 2x minus 4 you have here. If you now introduce the Lambert W function, it simplifies everything and gives you only the 2x minus 4. Yes. So if you simplify, it gives you only the 2x minus 4. So let's get right to business. So we have the equation. We can start by moving the plus x over to the right to become minus x. So I have 4 raised by x equals 1 minus x. And here I can divide both sides by 4 raised by x. Divide here by 4 raised by x. And also divide here by 4 raised by x. So this cancels this. I have 1 left here. And I have 1 minus x over 4 raised by x left on the right hand side. So we can now continue from here. So here I can write my 1 minus x over 4 raised by x equals 1. So here you can start by rearranging the left hand side. So here I can write this as 1 over 4 raised by x, then times 1 minus x. Notice if you multiply this back, you still get this expression on the left hand side, then equals 1. And then I'm going to rewrite 1 over 4 raised by x as following the law of indices as a number having a negative index. So it's going to be 4 raised to the power minus x. So this has become this, then times 1 minus x, then equals 1. And then from here, I will rewrite this 4 raised to the power minus x in terms of e. So if you look here, you have e raised to the power ln of a equals a. So if you decide to write a in terms of e, you can write it this way because this whole value is equal to a also. So you can write a in this way if you want to involve e. So writing a in terms of e gives you e raised to the power ln of a. So writing 4 raised to the power minus x in terms of e gives me e raised to the power ln of 4 raised to the power minus x. So let me do that now. So this becomes e raised to the power ln of 4 raised to the power minus x times, I still have my 1 minus x, then equals 1. And continuing from there, okay, I can write this here. I can start with 1 minus x times e raised to the power ln of 4 raised to the power minus x equals 1. And then I can move this minus x, which is the power for 4, over to this side following laws of logarithm. So I now have 1 minus x times e raised to the power minus x, then ln of 4 equals 1. So remember the goal. The goal is to make sure the power and the coefficient are the same. Once this power and the value here are the same, I can apply the Lambert W function, but they are not the same yet. So I can start by dividing both sides by this ln of 4. So divide here by ln of 4 and also divide here by ln of 4. And thereafter, I can multiply both sides again by ln of 4 all raised to the power 2. So I can say multiply here by ln of 4 all raised to the power 2. The same thing here, multiply here by ln of 4 all raised to the power 2. So I can say this cancels one of this one. I have ln of 4 left times this, and that gives me 1 minus x times ln of 4. Then times, I still have my e raised to the power minus x ln of 4 equals, then here, this cancels one of these. I have ln of 4 times 1. I still have ln of 4. Again, it is still not the same. The power here and the number here are still not the same. Okay, let me open the bracket here. Let me multiply ln of 4 by what I have in the bracket here, and let's see where it will lead us to. So ln of 4 times 1 gives me ln of 4 plus times minus minus. Ln of 4 times x gives me x ln of 4. Of course, everything times this e here waiting for us, e raised to the power minus x ln of 4 equals to this ln of 4 here. Again, the power and the coefficient here, they are not the same, so I cannot still apply the Lambert W function. So I still need to keep on trying to see if the power here and the coefficient here will end up being the same. That is the goal of the algebraic approach involving Lambert W function. So I need to, okay, yes, I can multiply the left hand side and the right hand side by e raised to the power ln of 4. Yes, let's do that and see. So I have ln of 4 minus x ln 4 dot e raised to the power minus x ln of 4 times e raised to the power ln of 4. So if I'm multiplying this left hand side by this e raised to the power ln of 4, I'll do the same thing to the right hand side. So I'll say equals to ln of 4 times e raised to the power ln of 4 also. And notice that here the bases are the same. I can multiply using the laws of indices. So I'm picking 1e and then I'm adding the power. So I now have minus x ln of 4 plus this ln of 4. So equals to, of course, I still have ln of 4 times e raised to the power ln of 4 on the right hand side. And then I still have my values here. Then times this ln of 4 minus x ln of 4. Notice that they are now the same. Look at the power up here and the coefficient here, they are the same. I have minus x ln of 4 plus ln of 4. Here to the same thing, I have minus x ln of 4 plus ln of 4. I can now apply the Lambert W function on the left hand side. Now to the right hand side, I have the same thing. I have my e. No, you need to have your e first, then the power and the coefficient will be the same thing. So here I have my e, and the power ln of 4 is the same thing as the coefficient here, ln of 4. So I can also apply the Lambert W function on the right hand side. Don't forget the rule. If you have the e and you have the power being the same thing as the coefficient, you can apply the Lambert W function and it simplifies or evaluates to one of them, which is the 6x. So I'm going to apply that logic here. So now I can comfortably apply the Lambert W function on the left hand side and on the right hand side. So doing that, now my w, which is my Lambert W function, into my ln of 4 minus x ln of 4 times e minus x ln of 4 plus ln of 4 equals to w also on the right hand side, since it's having the same format, the power and the coefficient are the same. I have ln of 4 dot e ln of 4, then close the bracket. So now, oh, I didn't close this other bracket here carefully. So now I can simplify. So the product log, which is still called the Lambert W function, of this value inside here simplifies to only the minus x ln of 4 plus ln of 4. So here now we now have minus x ln of 4 plus ln of 4 equals the same thing here. The Lambert W function of this simplifies to only the ln of 4 since they are the same. Just pick one of them, ln of 4, just like how I picked one of these ones too, minus x ln of 4 plus ln of 4 here. So now all this simplifies to this. So I can work with this now. This now looks easy and simple for me to solve. So I now have minus x ln of 4 equals to ln of 4. This plus ln of 4 becomes minus ln of 4 here, and it cancels out. I have 0. So I then have, finally, I have minus x ln of 4 equals 0. Divide both sides by ln of 4 first of all. This cancels this, and I have minus x equals 0 divided by this. Still gives me 0. Again, divide both sides by minus 1. I have minus 1 here. So this cancels this. My x equals to 0 divided by minus 1, still 0. So we still get the same answer as the graphical approach. So x equals 0. This is the way to do it algebraically involving the Lambert W function. That's it.